So I, like everyone else here, was presented with the challenge of handling a massive wave of web traffic and maintaining high quality service throughout that. So to address this challenge, I wanted as scalable a solution as possible in order to accommodate such a large volume of data and requests, leading me to my MVP, or as it's less commonly known, maximum viable product. So this was mainly covered by Joe, so I'll sort of gloss over this. But the question I had to address was essentially, how do I store such a large amount of messy data that could be retrieved in an efficient and organized manner? So listed are a couple of reasons why I chose Cassandra, but I'm personally going to highlight the inner workings of the database that will make my decision much more clear. So here we have an example of your typical relational database table where we have our employees by their employee ID and cars by their car ID. But let's say we wanted to access the employees that drive a BMW. We'd have to use a join to link the tables or query it or reformat the tables altogether. So a Cassandra table, we can see that in the first column, it's no longer a unique ID. It's something called a partition key, which we'll go over in the next slide. I also followed, similar to what Joe said, a query first approach, where the improvements to the database's efficiency is by designing the tables around the queries rather than the other way around. So when we read from the database, we only ever have to reference one table. And when we write, we only ever have to reference one table. So all the BMWs had the same partition key, all the Audis had the same partition key, but what does that actually do? So this is kind of what Cassandra looks like at a high level, where there's 5 nodes in a ring, and they're each assigned a token value. So one would receive a token value of 0, and it'd cover anything between 0 and 10. 2 would cover 10 through 20, and so on. So how the partition key comes into this is that it's passed through a hashing function, and the result is compared to the token to determine which node that the data goes onto. So you can see that before, all the BMWs will hash out to say, let's say 15, and they'll all reside on node number 2. So for me in questions and answers, if I was querying for all the questions and answers related to product ID 3, if the product ID was my partition key, then all the questions and answers related to product 3 will reside on that same node, which expedites the retrieval of that data. So the challenge of the work mainly came with the design of these tables, as Joe mentioned before, and it ensured that once I designed them well, that I would allow the power of Cassandra to do the rest. However, this required a lot of data manipulation during the ETL process. So thinking about the data in a query-first way was a new perspective on how databases could operate, and these were my results. I had a response time at around 12 milliseconds with 1,000 clients over 1 minute, which wasn't bad. But once I hit around the 1500 mark, the server began timing out. So I knew that I needed to improve the throughput of my server in order to handle more clients, which led me to Kubernetes. So Kubernetes helped me answer the question, how do I assign the right computers to run my servers on? And how do I balance out the distribution of my requests through load balancing? So again, at a high level, this is what Kubernetes looks like. So a diagram of the cluster is on the left and a node is on the right. So let's start with the cluster. So in this cluster, there's one master node in the middle and 3 worker nodes surrounding it. So the master node is given a specific configuration to construct worker nodes, and it handles the load distribution. So the deployment on that constructs these worker nodes, and in case any of them go down, it'll deploy another one with the blueprint that I provided. The worker nodes on the outsides themselves are remote computers that run pods. So the pods are similar to Docker containers that we've been working with. So the pods in my case are containerized versions of my server, which interface my database. So everything that I just described to you in the Kubernetes architecture had to be set up manually on AWS. So like the permissions, the types of machines, and S3, IAM, Route 53, EC2, all had to be considered. So this was a very, very high touch set of configurations, like probably the most that I've ever had to deal with, and it took a lot of patience and testing to work. So once the cluster was constructed, I assigned the entire service a load balancer, and that exposed a public IP address that I could then test against. So as a reminder, these are my last test results, and after load balancing, the results were simply remarkable, speeding up the response times by an incredible -1 milliseconds, which was not very encouraging, but with David's blessing, I began tuning up the dial, and I passed my original benchmark of 1,500 clients, going to 2,000 with minimal loss, and my max throughput that I got was 3,200. So at the final, like, what did it cost? Well, it cost me the trust of my girlfriend, the lives of countless T2 micro instances, and a total of $4.34 to make this presentation possible. I found a lot of educational value in this exercise. The end result that I had was a scalable database being dynamically served up by my load balancer. And SDC demonstrated to me the power of organized data collections, container orchestration, and how by rigorously designing system infrastructure, you can construct a really solid foundation for building massive web entities.
Awesome.